Hello everyone, this is Ozen from the Ozen Engineering team. This is the third part of the video that I work with dynamic mesh motion. In the part 1 and 2 I already talked about how to set up the model for the dynamic mesh motion for a model in Ansys Fluent. So in this part we want to show you just how to define the mesh motion if it is only purely horizontal or purely vertical, or it's a combination of the x and y components. And usually we receive this information from the measurements, or if we have the FSI, which is fluid structure interaction, it is from Ansys mechanical. So whatever way that you prepare the motion, or if it is, for example, in this example we are using only sinusoidal motion, so whatever that you have it, you need to use it to define a profile for the mesh motion, or using a UDF to define the function for the moving mesh. Please watch this video. About the mesh motion, we use a profile. Basically we have vertical motion, that it is like a sinusoidal wave going up and down. At first, as you see, that up to here the mesh should go up, and then from here up to here the mesh should go down, and then back to the original position. So it is just one cycle. Then we're going to have the next cycle, then again going up, going down, and then back to the original position. And if it is horizontal motion for the mesh, then the mesh will go to the right up to here, and then move back to the left up to here, and then move to the right and back to the original position. And this is for one full cycle. And for the next cycle, going up, moving to the right, then moving to the left, and then again move to the right to back to the position that we have. An example of dynamic mesh motion. This is set up for dynamic mesh motion. We have a profile for dynamic mesh motion. This is for the profile, and it is for vertical motion, so in y direction. It is for smoothing and remeshing together. We start to preview the mesh motion. You can see that the mesh is moving up. Okay, let's check horizontal motion. We already read the profile that we have the time and x position. This is the profile that we have first time, and then the next section it is for the x component, so it shows that the position of the nodes. And be sure that to mention that we should have same data points for the time and for the positions. Let's start previewing the mesh. Say that for 25 or 10. And you can see the iterations for the each time step that you are seeing that here, and the maximum minimum change in the volume. You can see here that the moving nodes, because this wall is stationary or deforming, but for this one you can see that it's just moving to the right. You can see that. And we see that the mesh here is deforming. Next step is if we have the general planar motion, when we have the profile for the mesh motion in terms of time, x components and y components. So previously we had x only or y only, which were for horizontal motion or vertical mesh motion. Now we have together x and y components together. So we read the profile, time, xy components is here also printed in the console. Let's see what's happening to the mesh motion. Let's start with 10 times second. As you can see, the mesh is going up and also to the right. 10 time steps. Let's go for larger time step. Now this is general planar mesh motion. You can see that we are still going to the right and up, moving upward. We're still going up and to the right, and now we started coming back to the left and downward. You can see it from here. If you check the mesh grids with here, you can see that it is easier. So in this video I showed you how to use dynamic mesh motion for having the moving mesh when we want to have only vertical motion going up and down, or if we want to have the horizontal motion purely only to the left or right. So this is a replication of the vibration, for example, that we can receive from the measurements when we have the data, or the third motion, that it is a combination of horizontal and vertical motions, and also showed you the profile that I use for this video. In the part 1 and 2 of the series of this video that I already published, I showed you how to create this model in Ansys Fluent meshing, and what steps you need to follow up to define this dynamic mesh motion. Thank you for watching this video.